Today we are doing 10-2 where we are talking about tangent lines to a circle. We have two theorems here. If a line is tangent to a circle, then it is perpendicular to the radius. So this part right here is perpendicular. Okay. And then if two segments from the same exterior points are tangent to the circle, so tangent meaning it just touches and then brushes on by, then they are congruent. So that side must equal that side. So open up your foldable. Let's fill in our words here. In this example, we have line L, so it's a cursive L, is tangent to circle S if and only if line L is perpendicular to ST. So in this case, it does show that it's perpendicular. That means it's 90 degrees, in case you forgot what perpendicular is. What is the point of tangency? That means where's the point that is just barely touching the circle and then scooting off? That happens at T. Okay. The other side, if we have QP and RP, and they are tangent to the circle, then those two segments are congruent. If you don't remember what that symbol means, maybe actually write out the word congruent as a good study tip there. Okay, so what that means is this line is equal to that line, or we say QP is congruent to RP. Okay, so let's use all of those things that we just talked about to answer some questions here. Okay, so we want to find the measure of angle BCM. So that means I'm actually finding the angle of C there. Well, according to our theorem, that one has to be perpendicular, so it has to be 90 degrees. Okay? All right. If the length of CM is 12 and BC is 5, we want to find EM. So what we're going to do, because we know this part is 5, because part of a circle is from the center to the outside edge is the radius, and it's the same no matter where that goes. Okay? But if we look overall here, we actually have a right triangle. So we can do A squared plus B squared equals C squared. Okay, so that's 169 equals C squared. Take the square root. 13 equals C. Now remember, 13 is the whole length, right? We need to take 13 and subtract that 5 that we know to get just the upper piece here, which is 8. Okay. We're going to change our colors up here because on number 5, it's a similar question. I don't really know why I'm not going in order 1, 2, 3, 4, 5, 6, but we'll get to all of them. Okay, find the length of CM. So we're talking about CM again. But if BC is 12 and BM is 20. So again, we have the right triangle, so we will do A squared plus B squared equals C squared. However, we know the hypotenuse, so we know C squared. We do not know one of the sides. So B squared is going to equal 20 squared minus 12 squared. which is 256. Take the square root, and b equals 16, which is what we're looking for there. Okay. Find the length of CM if CM equals 5x minus 9 and MZ is x plus 7. Well, remember our other theorem that we talked about said that these had to be equal to one another. So I'm going to set them equal to one another and solve. So x must equal 4. Now notice we have not actually solved or answered the question. I need to plug that back into CM. CM is 5 times 4 minus 9, which is 20 minus 9, which is 11. Okay. All right, picking a different color here. If CBM is 60, that means we have a 30, 60, 90 triangle here. And the long leg is 13 square root of 3. We want to find the short leg. So remember, long leg always equals short leg times square root of 3. So in this example, 13 square root of 3 equals the short leg times square root of 3. Well, we can cancel the square root of 3's out. The short leg must be 13, so that is our answer. That comes from our special right triangle. So 30, 60, 90 special right triangles. That was 8-1, part 2. All right, and last but not least, find the length of XE if BM is 25 and ZM is 20. So again, we have a squared plus b squared equals c squared. So 20 squared plus x squared equals 25 squared. I'm going to subtract. That gives me 225. Square root of 225 is 15. So here's what that means. That means that BZ is 15. Okay. What we want is XE. Notice that is 2 radii. So it's a radius here and a radius here. So all I have to do is multiply this by 2 to get the full length of 30. All right, those are all of your examples for tangent to a circle.